Hello everyone and welcome once again to my channel. Today I'm going to show you how to solve this interesting Newton's second law question we have right before us. The question reads, two masses m1 and m2 where m2 is greater than m1 are connected by a light cord that passes over a massless, frictionless pulley as shown in the figure below. Find the magnitude of acceleration of the two masses and the tension in the cord. Consider mass 1 equal to 4 kg and mass 2 equal to 6 kg. Well, this is a Newton's second law question, and I'm going to explain it in a way that you understand it and you'll be able to solve more problems like this in the future without stress. Now let's begin. There are certain tips and tricks you need to know whenever you're solving a Newton's second law question. And those tricks are, first of all, if there is no friction, okay? If there is no friction, then the acceleration is actually going to be the same on both ends. All right, so the acceleration of the mass 1 and the acceleration of the mass 2 are going to be the same. So you are going to find just one acceleration. They are going to accelerate at the same rate once this cord is released. That's the first thing that you need to know. The acceleration would be the same. And secondly, the tension on both ends would also be the same. So the tension for mass 1 and mass 2, they will all be the same. Okay, now you don't have to start looking for separate tensions. No, the tension for mass 1 and the tension for mass 2 are all going to be the same at all times. Now, the third thing you need to know is that you have to consider the direction of motion. The direction of motion is very important because it's what's going to help you create the right equation for each mass. Why are we talking about this? Because we are going to create two equations here. The first equation would be for object 1, while the second equation would be for object 2. Okay, so whenever you are given a Newton's second law question or a question on forces where there are two or more masses, you are going to create equations based on the number of masses given in the question. If you have only one mass, you're only going to create one equation. If you have two masses, you're going to create two equations. If you have three masses, you're also going to create three equations. That is how it works. So in this case right now, you're going to first of all determine the direction of motion, and from there you now create your two equations. All right, so let's begin with this. So there is no normal force problem here because the masses are not hanging or they're not resting on a surface. So we are not going to consider any form of normal force. Let's collect our data and start solving the problem. So this is for object 1, and here we have our data. Our mass 1 is equal to 4 kg, and then we are also going to use our g, okay, because gravity is involved because it's pulling them downwards. Okay, gravity is involved, it's pulling both masses downwards, so we have to include our g. Our g we can use 9.8 meters per second square. And what next do we have here? Okay, for the object 1, that's all we've got here. And we asked to find the acceleration. We don't know what that is. And we also asked to find our tension. We also do not know what that is. Okay, so this is what we have for object 1. And we're going to use this to create our equation. Now for object 2, I'm going to also collect our data. Mass 2 is equal to 6 kg. And our g is also going to be 9.8 meters per second square. We do not know the acceleration. We do not know our tension. So we're going to find the two of them right now. So we're going to create two equations for this, like I said. But first of all, we need to determine the direction of motion. That is the most important thing in this case. Okay, so let me give you a little bit of explanation in this very case. I needed to understand something when it comes to solving Newton's second law problems or questions. Um, for example, let's suppose you have a free body diagram like this. Then you have your upward force, which is going to be your tension, and downwards you have your weight, which is also mg. Okay, so your tension is upwards, your mg is downwards. If the object is stationary, that is, if there is no acceleration, it means the object is not moving, you consider upwards as positive and downwards as negative. Okay, but if the object is moving, it does not matter the direction of motion. If it's going downwards, let's suppose we have another case where the object is going downwards. Okay, and here, this is the object represented by a dot. Here, tension is upwards. So if the object is going downwards, mg now becomes a plus because it's the direction of motion. Always, that's how it works. While all forces that are opposite the motion or opposing the motion becomes a negative. So if there is acceleration in the downward direction, your down becomes positive while upwards becomes negative. That's how we're going to analyze this right now. That's why it's very important to know where your objects are headed towards. Now, if mass 1 is 4 and mass 2 is 6, it means that 6 is greater than 4. Now, if I ask you, where do you think this masses is going to accelerate towards? Is it going to accelerate towards M1? That is it going to go down? Or is it going to go down towards M2? Well, you know that 6 is greater than 4. Therefore, it's going to go down this part, okay? Because this is a 6 kg, and here you have your 4. So it's going to go down towards a 6 kg, and that's how it's going to be. So we're going to consider all forces, okay, down the 6 kg block as positive, okay, while every other thing that opposes the 6 kg is going to be a negative. Okay, so now let's go ahead and analyze this. Remember, it's going down towards this direction. It's going this way. Now, let's begin with the object 2. Let's create equations for the object 2. So if you look at this right now, for the object 2, let me clean this so that I show you what I mean. Let's suppose that this is our object 2, okay? So if you look at this right here, mg is pointing downwards, okay? And this is where it is moving towards. This is going to fall down, so it means that it's going to go this way, okay? It's going to go this way. It's actually going, so this one here would follow suit, okay, and go down with this the second mass, which is m2. Now, mg is pointing downwards, okay? So tension is upwards. Therefore, your tension becomes negative because it's kind of opposing the motion. There is tension in the string here, okay? And down here you have mg, okay? So since it's going down, your down becomes a plus, your upwards becomes a minus. That's how it is. So now let's now create our equation. We say summation of forces in the y direction is equal to m2a. We're making this distinction because m1 and m2 do not have the same magnitude. They do not have the same value. So we make the distinction. We say summation. This means summation. This sigma notation here means summation of all forces in the y direction is equal to m2a. Okay? Now, what are the forces in the y direction? We've got the first force here, which is pointed downwards, which is mg. So we say m, okay, 2g is going to be m2g, okay, minus tension, okay, m2g minus tension. So this m2 means mass 2 multiplied by gravity minus tension is equal to m2a. Okay, now we want to make tension the subject. Since the acceleration will be the same for object 2 and object 1, we can make tension the subject on both sides and equate them to solve for acceleration. That's what we are going to do right now. So to make tension the subject, we simply move the m2a to the other side, and the negative t to the right. So we have M2G minus M2A is equal to tension. We call this our equation 1. Okay, that becomes our equation 1. And then let's now solve for equation 2. Okay, I started with object 2 because it's going down this way to avoid mistakes. All right, since it's going down, let's now analyze our object 1. Let's analyze this. So this is our object 1. Here you have your weight force pointing downwards. We've got our weight force pointing downwards. We have our tension upwards. Okay, now in this case, do you think that the tension will be positive or a negative? And do you think the weight force will be negative or a positive? Anyways, let's see how this looks like. So if you release the masses, they're going to go this way, right? Okay, towards a 6 kg block. This means that all the forces that are aligned or that are moving towards the direction of motion becomes a positive. That's how it works. Always consider the direction of motion. Here, since it's going this way, okay, it means that your tension, which is in the string, there is tension right here, there is tension right here, okay? So the force on a string is called a tension force. Since it's going towards this way, the tension for this mass 1 is going to be a positive value, while M1G is pointing downwards. It's kind of opposing the motion, so it's going to be negative, okay? The tension will now become a positive, while M1G would be a negative because it's going down, like it's opposite the motion. It's trying to oppose the motion. So all forces in line with the motion becomes a plus, while all forces opposing the motion or going in opposite direction to the motion becomes a minus. So we can now create our equation. We say our summation of forces in the y direction is equal to M1A. We're talking about our mass 1 right now. We have already created an equation for mass 2. Let's now create for mass 1. So we say M1A. And then what are the forces in the y direction? The first one here is tension. There is tension in the string. So we say T. What other force? So we have M1G is pointing downwards because it's opposing the motion since it's going to go this way. Okay. So this force going downwards, it's opposing the motion. So it becomes a negative minus M1G is equal to M1A. All right. Now let's proceed. Let's make tension a subject and create our equation 2. So we say tension is equal to, I'm going to move the negative M1G across. This now becomes equal to M1A, okay, minus, plus M1G. Since it's a negative, if it crosses over, it becomes a positive, and this becomes our equation 2. All right, it doesn't matter whether you start with M1A and create your equation 1 with this, or you start with, it does not really matter. Provided we're solving for one tension, we'll still arrive at the same solution. I started with the direction of motion so that we can understand this concept better. Now that we have created 2 equations, what's the next step right now? Well, we have to start solving the problem. Now look at this right here. So tension is equal to M1A plus M1G. And the same tension is also equal to M2G minus M2A. Okay? So since tension is equal to the both of them, we can equate the 2 of them together to solve for acceleration. Okay? So we say equating 1 and 2. So we shall now obtain, here we shall have M1A, okay? Okay, let me just begin from equation 1. We have M2G minus M2A is equal to M1A plus M1G. Okay, I just equated 1 and 2 to solve. Now, what's our mass 2? Our mass 2 is 6. Our mass 2 is 6. You can see it here. Our mass 2 here is 6 kg. Our mass 1 is 4 kg. And we're using the same G for the two of them. Now, you've seen there is no tension here anymore. We can find our acceleration first, and then we find its tension. So here we say our M2 is 6 multiplied by 9.8 minus our mass 2 again is 6. Okay, so 6 times A, well, let me do it this way, multiplied by A is equal to our mass 1 is 4 multiplied by A plus our mass 1 is 4 multiplied by 9.8. Now let's go ahead and multiply them out so that we can find what we're looking for. So 6 multiplied by 9.8 is going to give us 58.8. So here we have 58.8 minus 6 times A will give us 6A is equal to 4 times A will give us 4A plus 4 times 9.8 would give us 39.2. Here we have 39.2. Now, what do we do right now? To solve for A, we're going to move the negative 6A to the other side, and we move 39.2 to the side. Now, let's do that. Here we have 58.8. It's a plus here. If it crosses over to the other side, it becomes a minus. Minus 39.2 is equal to, here we have 6A plus 4A. Now, 58.8 minus 39.2 is going to give us 19.6. Here we have 19.6 on the left is equal to 10A. Now, to solve for A, we simply divide both sides by 10. By 10. When we do the division, we have that this one cancels out with this. Our A is now equal to 19.6 divided by 10 is going to give us 1.96. Therefore, our acceleration is 1.96 meters per second square. So, since they are connected to the same string or to the same cord, they will have the same acceleration. That's one thing that you need to know. And secondly, if they are also connected to a massless string or massless cord, then the tension here and the tension on the other side will also be the same. Since we have found our acceleration, what's the next thing to do? We can now go ahead and solve for tension using either equation 2 or equation 1. Okay, we have our A now, we have mass 1, we have mass 1. We can solve for the tension. Or we can also use this one. We can also use equation 1 where we have mass 2, we have our acceleration right now, we have our G, we have our mass 2. We can solve for the tension. So if you are correct, irrespective of the equation used, whether 1 or 2, you arrive at the same solution. Now let's see what we can obtain from this. So I will say solving is our part B. Solving for tension. All right. So we use equation, let's use equation 2 to solve. So equation 2 is T is equal to M1A plus M1G. So we say that the tension is equal to M1A plus M1G. Now let's plug in our values and we solve. Our tension here is going to be equal to our mass 1 is 4 multiplied by our acceleration in this case is 1.96, which we have found already. 1.96 plus our mass 1 is 4 again multiplied by our G, which is 9.8. Now let's multiply this out to see what we're going to obtain. So 4 multiplied by 1.96 is going to give us 7.84. Here we have 7.84 plus 4.9.8 is going to give us, let me see, so 4.9.8, or 4 times 9.8 rather. 4 times 9.8 is going to give us 39.2. So here we have 39.2. Let's add them together. Our tension will now be equal to 39.2 plus 7.84. Our answer is 47.04 newtons. Okay, tension is measured in newtons. So this is the tension in the cord or string. But we can also verify our solution using the next equation. We used equation 2 to solve, and we discovered that the tension is 47.04. We can also use equation 1 to verify our solution. If we arrive at the same solution, it means that we are correct. That's how it's going to be. So we say M2G, okay? So we're just verifying right now, verification. Here we have M2G minus M2A minus M2A is equal to G. Now let's substitute our values. Our mass 2 is 6 kg, and we're multiplying it by 9.8 minus our mass 2 is 6. We multiply this by our acceleration, which is 1.96. Okay, this is equal to T, not a G. I made a mistake. Please pardon me for that mistake. Is equal to T. All right, so let's multiply. 6 times 9.8 will give us 58.8. Here we have 58.8 minus 6 times 1.96 is going to give us 11.76. 11.76 is equal to our tension. So let's add them up, or let's subtract them rather. 58.8 minus 11.76 is equal to 47.04. So we have that our tension is equal to 47.04 newtons. Okay. So you've seen we got 47.04 here. We also got 47.04 here, which means that our solution is correct. All right. So thank you for being here. I believe you've understood how to solve this problem. And in the next video, I'm going to be talking more about Newton's second law problems. Thank you for being there, and see you in the next video. Bye.